So this is a small Java program. So let's try to understand that what are the elements that we have used, or what are the elements that we need in order to write a Java program. So starting from here, this is public. So this is a access modifier. Let me write it here. So it represents visibility. So by visibility, I mean that this access modifier control that what will be the level of access to other parts of the program of this code. So how other parts of the program can access the code that is inside this class. So this is access modifier and it controls visibility. We will talk about access modifier. Now let's have an overview of what are the things that we are using here. Next is a class. Class is a keyword. So as you can see in the program that everything that we have written is inside a class, and in Java everything that you write is inside a class. So all the code that you write has to be inside a class, and class is a basic building block of Java programs. So you can think of it as a class as a container, and everything that you write has to be inside any class. When you go on to write a Java application, you will have several number of classes. So this is a class, and class is a keyword. Here, this is the name of the class, and what happens is that when you go on to write the name of a class, you have to follow several rules. First one rule is that you have to start the name of the class with a letter, and it is a general convention to have it in camel case. So let's say I have to write just one word. Let's say I have to write class name as simple, so I can simply write this as the first alphabet being capital and rest of them being in small letter. So we follow camel case generally for writing name of the class. So this is the class, and all the code is inside the class. Coming here, this is main, and whenever you run a Java program inside a JVM, then JVM searches for main and it starts the execution from main function. And this is again a access modifier for this method. Static here is a keyword. By static, so whenever we declare a method as a static, we don't need to create objects to access those methods. It actually saves memory, and main is something that is executed by the JVM, so we declare it as static. Again, we will be discussing a lot about static later on. As of now, just try to understand we have declared main as static so that we don't need to create objects, or we don't need to access main using any objects. This is a command line argument. Again, we will talk about it. And this system.out.println, this is used to print hello world. So we want to output any statement, we can output using println. So these are the elements of a small Java program. We will discuss about each of them in details. Now let's say I have written this Java program. So I have downloaded the JDK, I have Java installed my system, and I have written this program in a text editor. Whenever I save a Java program, I have to save it from the name of the public class. So whatever public class we have to save the program on the name of that public class only. So this program will be saved as first sample dot Java. Now how do I run this program? So before I go on to run this program, I have to compile this program. So I write Java C on a terminal and first sample.java. Nowadays we have many softwares which help us to write the program, like Eclipse, in which you have UI for running and compiling the programs. And in case you are just simply writing the program on a text editor and you have to compile a Java program, you can compile using Java C for sample.java. So after you have done the compilation, first sample.java gets converted into a bytecode and we get first sample.class. And when I have to run this particular code, I run using Java first sample, name of the program. So this is how I compile a Java program and run a Java program. First, let's see what happens when we compile a Java program. So as we saw that, let's say I have a file for sample.java. When this program is compiled by a compiler using Java C, a bytecode is generated. And this bytecode has dot class extension. So a new file will be created, file sample dot class. After this file sample dot first sample dot class is created, I have to run this particular class file. So after we have this dot class file, after compilation, we have to execute or run this bytecode or dot class file. How this running happens? We run this dot class file inside a JVM. And we have seen that JVM stands for Java Virtual Machine. We will discuss in detail about JVM. As of now, try to understand that how this dot class file runs inside a JVM. So whenever we have a dot class file, we have a class loader which loads this dot class file in a JVM. And after this file is loaded, we have a bytecode verifier which verifies the bytecode. So after the bytecode is verified, we have interpreter. So what happens in interpreter is, we know that in compilation, after compilation, the source code is converted into machine level code, and then that machine level code is executed. But interpreter directly executes the code. It does not do the conversion of bytecode to machine level code. It directly does the execution of instructions. So we have the runtime environment and interpreter does the execution. So this is how a dot class file is run or executed. Now we have heard of these words JVM, JDK and JRE, and you will often come across them when you're dealing with Java. So let's try to understand what are these terms and what are the difference between these. So what happens is that whenever you have to download a Java, whenever you are asked to download a Java or install a Java in your system, you download JDK. The whole package is JDK. JVM and JRE comes inside JDK. So we can think of JDK as a package. If I try to see these three things, so I can think of JDK as a package which contains JRE. This is Java runtime environment. This is Java development kit. It has Java runtime environment and it has development tools. Development tools like Java, Java C. So whenever I do this Java C and name of the Java file, so this is actually a tool or a program that is used to compile the Java code. So this is a tool to compile the Java code, and this JDK has these tools in it. So JDK is a whole package that has JRE, which is Java runtime environment, and these tools. This JRE has JVM inside it. It has JVM, which is Java Virtual Machine, plus it has the jar files or the libraries that are there in the Java. I'll see what jar file is. I'll let you know. It has jar files plus other files. So now let's say what is a jar file. So let's say I've built a calculator application. So what happens in a Java application is that you have several dot class files. So let's say I've written a Java program for addition. I've written a separate class for subtraction. So for several functions of calculator, I have written a separate class file and I've saved them as dot class. So let's say I have addition.class, subtraction.class. So what will happen? That whenever I have to build a calculator app, I will write all these dot class files and I will pack them inside a dot jar file. So I can say that dot jar is a file format in which we can distribute a Java application, and it contains all the dot class files that is required for a calculator app or any Java application. So it is a collection of these .class files. So when I say that this JRE has jar files and JVM files, so we know that Java has lots of libraries. We'll come across the libraries as we go through the code. So JVM is for running the or executing the code, and jar files are the libraries that we have. So this JRE contains this JVM and these jar files. So JDK is the whole package that contains JRE plus development tools, and then JRE contains JVM plus Java files and other files. Now let's see what JVM is and what are the components of a JVM. Before I go on to discuss JVM, there's one thing to understand, that JDK and JRE are something that actually exists. JDK exists in the system. Both of them you can find in your system. JVM is an abstract machine. It is just a set of specifications which allows a program to run, which provides a runtime environment for a program to be executed. So these are the things that actually exist. You can find them in the system. You can go and find a file that is JDK. You can find a file named JRE with a version of it, but you will never be able to find a JVM file. So this is something that exists virtually. It is a, as the name suggests, virtual machine. So this is a JVM architecture. So what happens in a JVM is that JVM is an abstract machine. As I said before also, that it does not actually exist. It is just a concept, or it is just a specification that provides runtime environment in which Java bytecode can be executed. So whenever you run a Java program, a JVM instance is created. So whenever you run a Java program, a JVM instance is created using these specifications. So let's see what are the elements that a JVM has. So first of all, a JVM has a class loader. This class loader does the task of loading the .class files. Then we have a heap area, we have a stack area, we have registers, we have class area. This is also known as method area. So what happens in heap is a part of memory in which we store information about all objects. So whatever is related to an object is stored in a heap area. Now what is a stack? Stack is used to store method calls and local variables. So stack is used to store method calls and local variables. We have PC registers that stores the address of the current execution of a thread. So whatever execution is happening, the address is stored in PC register. Then we have a class area, also known as method area. In this, we store all the class level information like name of the class, static variables, parent of a particular class. So all the class level variables, whatever we have, is stored in class area. Then we have native methods. So what happens that we have a native method library in Java. So these are the libraries that contain code written in C and C++. So all these methods are stored in native methods. So depending upon what is the type of code, these memory areas are filled. Now we have an execution engine. So what do we have in execution engine? In execution engine, we have a interpreter. We have just-in-time compilers, also known as JIT. And we have processors, virtual. We have virtual processors. Interpreter we have seen before. So what happens in with JIT is just like another compiler. It's just that it is used during runtime. So it is known as just-in-time compiler. So what happens that in the bytecode, let's say we come across a code that is executed very frequently, or let's say we come across a part of code that is very similar. So what happens is that this just-in-time compiler converts that particular part of the code to machine level code. It compiles a part of the code such that it enhances the speed. So what is happening here is that interpreter is executing all the instructions, but this is a bytecode. It is executing the bytecode. What happens is that This just-in-time compiler goes through a particular section, or optimizes or compiles a particular section to machine level code such that the speed is increased or the code is optimized so that we have a high performance. So it supports high performance. That's how just-in-time compiler is used during execution. Next we have native method interface. Again, I said that Java has native libraries which contains methods written in other languages like C and C++. So this native method interface acts as an interface between the execution engine and the Java native libraries. So summarizing the JVM, the task of JVM is to load the code, which is done by class loader, verify the code, execute the code, which is done using execution engine, and provide runtime environment. So this JVM does the whole task of loading, verifying, and executing the code. And obviously when we are executing a code, we need to store several parts of our code or several parts of our program. So we store these things in the heap, stack, PC register, class area, and native methods depending upon the kind of element that we have to store. So we have a class loader to load the class files in JVM. We have these memory areas to store the data, and then we have execution engine to do the execution. This execution engine has a virtual processor, interpreter, as well as just-in-time compilers. We have seen JDK, JVM, JRE. Now next discuss very important question. Okay. Another very important question that we have during interview is, what is the difference between C++ and Java? Because as we know that both of them are object-oriented language. Talking about the difference between C++ and Java, we have discussed some of these before also. Like C++ has the concept of pointers, whereas we don't have pointers in Java. Another difference is C++ is platform dependent, whereas Java is platform independent. Then we have goto keyword in C++ and we don't have goto keyword in Java. Again, we have structures and unions in C++ and we don't have structures and unions in Java. One more important thing is that C++ supports multiple inheritance. And Java does not support multiple inheritance. In Java, we use interface to achieve multiple inheritance. We'll talk about interface. Again, as we have discussed before, that C++ supports operator overloading and we don't have operator overloading in Java. C++ is a compiled language. So it just uses compiler. The compiler compiles the C++ program in machine code and that is executed. Whereas in Java, first the compiler compiles the Java code into bytecode. So Java uses both compiler as well as interpreter. We have built-in thread support, as we have seen that we have built-in thread support for Java, and this C++ has no built-in thread support. It uses third-party libraries. So these are some of the differences between C++ and Java.